In June 2025, astronomers detected something passing through our solar system. Something that had traveled from another star. Something that shouldn't exist according to everything we know about comets and asteroids. They named it 3I Atlas, the third confirmed interstellar visitor to our cosmic neighborhood. But as the world's most powerful telescopes turned their gaze toward this distant object, they discovered something deeply unsettling. It wasn't behaving like a comet. It wasn't behaving like an asteroid. In fact, it wasn't behaving like anything we'd ever seen before. By December 2025, Harvard astronomer Professor Avi Loeb had documented 15 separate anomalies, 15 behaviors that defied natural explanation. And with each new observation, one controversial question grew louder: could we be witnessing our first confirmed alien probe? This is the story of 3I Atlas, an object that refuses to follow the rules, an enigma that's dividing the scientific community, and a mystery that could change everything we think we know about our place in the universe. On June 12, 2025, the Asteroid Terrestrial Impact Last Alert System, ATLAS for short, picked up an unusual signal, a faint streak of light moving through space at extraordinary speed. Within hours, astronomers confirmed what made this discovery extraordinary. The object's trajectory was hyperbolic. It wasn't orbiting our sun. It was passing through. A visitor from the vast darkness between the stars. This made 3I Atlas only the third interstellar object ever detected. The first was Oumuamua in 2017, a cigar-shaped object that sparked similar controversies. The second was Comet Borisov in 2019, which behaved exactly as comets should. But 3I Atlas? It was different from the moment we found it. The object was traveling at approximately 30 kilometers per second, fast enough to confirm its interstellar origin. Its trajectory showed it had entered from beyond the solar system, curved around our sun, and was now heading back into deep space. Astronomers initially classified it as a comet. Standard procedure: interstellar objects typically show comet-like characteristics as they heat up near the sun. Ice vaporizes, creating the familiar glowing tail and coma, that fuzzy cloud of gas and dust. But as observations continued, something became clear: 3I Atlas wasn't following the script. Professor Avi Loeb, former chair of Harvard's astronomy department and head of the Galileo project, began documenting anomalies, behaviors that didn't fit the comet model, characteristics that suggested something far more unusual. By mid-December, his list had grown to 15 distinct anomalies, each one statistically improbable, together forming a pattern that demanded explanation. The question was simple, but its implications were profound. What exactly is 3I Atlas? Let's examine what makes 3I Atlas so unusual. These aren't wild speculations. These are documented observations from some of the world's most sophisticated instruments. 4. Anomaly 1, the retrograde orbit. 3I Atlas travels in a retrograde orbit, meaning it moves opposite to the rotation of our solar system. That's unusual, but not impossible. What's remarkable is the precision. Its orbital plane is almost perfectly anti-aligned with our solar system's ecliptic. The statistical probability? Approximately 0.2%. It's like throwing a dart at a spinning wheel and hitting a target the size of a pinhead. 430 Anomaly 2, the planetary dance. The object made close approaches to multiple planets, Jupiter, Saturn, even Mars. Yet it maintained precise distances from Earth, never coming dangerously close to our planet. For a natural object on a chaotic interstellar trajectory, this is extraordinarily fortunate, or precisely calculated. 5. Anomaly 3, the missing tail. Despite passing close to the sun, 3I Atlas showed no typical comet tail. Comets develop tails as solar radiation vaporizes surface ice. The lack of a tail suggests either this object has no volatile materials, or its surface is something other than ice and rock. 530 Anomaly 4, the wobbling jets. Here's where things get truly strange. Hubble's Space Telescope images revealed massive jet structures stretching millions of kilometers from the object. But unlike normal comet jets, these were wobbling, changing direction, behaving erratically. Loeb described them as a high-altitude jet detected in the comet's structure, jets that shouldn't exist in a natural comet. 6. Anomaly 5, the nickel mystery. Spectroscopic analysis revealed something unprecedented, the presence of nickel without corresponding iron. In nature, these elements appear together. They're forged together in stellar cores. But there's one place where nickel appears without iron, in industrial production. Specifically, the carbonyl process used in manufacturing nickel alloys, a technological process, not a natural one.
This forms nickel tetracarbonyl. This modern metallurgy plant utilizes advanced hydrometallurgy to refine nickel, a stark contrast to traditional methods.
Anomaly 6, the light signature. The object's light reflection pattern is unlike anything in our database of comets and asteroids. It doesn't match the spectral signature of ice, rock, or metal from any known celestial body. Professor Loeb noted this as having a light signature unlike anything we've ever seen. The object reflects light in ways that suggest an unusual surface composition or structure. Anomaly 7, irregular rotation. The object's rotation is irregular, suggesting an asymmetric shape or internal structure. Natural objects typically settle into predictable spin patterns over millions of years. 3I Atlas rotates chaotically, as if its mass distribution is uneven or deliberately designed. 720, Anomaly 8, trajectory deviations. The object's trajectory showed slight deviations consistent with controlled adjustments, not random gravitational influences. These micro-corrections are subtle but measurable. Natural objects don't adjust their course. 740, Anomaly 9, perfect timing. The timing of its perihelion, closest approach to the Sun, occurred at solar opposition, when Earth was on the opposite side of the Sun. Another statistically improbable alignment. Was this object deliberately avoiding close observation from Earth? 8. Anomaly 10, brightness variations. Its brightness variations don't follow patterns of typical tumbling asteroids. The light curve, the pattern of brightness over time, suggests either an unusual shape or an object with reflective and non-reflective surfaces in unexpected configurations. Anomaly 11, the sunward jet. The object maintained a sunward jet after its gravitational deflection, suggesting active propulsion or guidance. This jet pointed toward the Sun even after the object had passed perihelion and should have been outgassing in different directions. Temperature anomalies. Temperature readings show unexpected heat distribution across its surface. Some areas are warmer than solar heating alone can explain, others are colder, as if insulated or shielded. 9. Anomaly 13, acceleration profile. The object's acceleration profile doesn't perfectly match gravitational models. There are tiny discrepancies, fractions of a percent, but they're consistent, as if the object is producing thrust we can't detect. 915, Anomaly 14, structure. D. Radio emissions. Radio emissions, while faint, show patterns that some researchers describe as structured. Not random noise, but organized in ways that natural sources rarely produce. Anomaly 15, the destination. Its departure angle suggests a trajectory toward a specific stellar destination, not random wandering through space. When you trace its path backward and forward, it appears to be traveling from one star system to another, deliberately. Individually, each anomaly could be explained away. Unusual, yes, but not impossible. Together, the odds become astronomical. Let's examine what makes 3I Atlas so unusual. These aren't wild speculations. These are documented observations from some of the world's most sophisticated instruments. Pause 3 seconds. Individually, each anomaly could be explained away. Unusual. Yes. but not impossible. Together, the odds become astronomical. Professor Avi Loeb isn't just any scientist making wild claims. He's a respected Harvard astrophysicist, former chair of the astronomy department, and former member of the President's Council of Advisors on Science and Technology. His publication record includes over 1,000 Pascal per second and 8 books. He's advised NASA, the National Science Foundation, and served on numerous scientific committees. This is not a fringe figure. This is mainstream science asking uncomfortable questions. His argument is methodical. I'm not claiming that 3I Atlas is technological. I'm stating that we should consider its anomalies with this possibility in mind. It's an important distinction. Loeb isn't declaring this is an alien probe. He's asking, shouldn't we investigate that possibility with the same rigor we apply to natural explanations?
Represents a monumental leap forward.
The scientific community is divided. Critics argue that Loeb is falling victim to confirmation bias. They point out that anomalies are called anomalies because they're unexpected. That doesn't make them artificial. Princeton astrophysicist Josh Wynn challenged Loeb directly in a published exchange. Wynn's concern, the problem with calling something anomalous after discovering it, is that you're assigning low probability to something you didn't predict. It would have been equally anomalous if the orbit aligned differently, or if it approached different planets, or showed any number of other unusual characteristics. In other words, we're pattern matching after the fact. We're seeing faces in clouds, finding meaning in randomness. Other scientists publish studies attempting to explain 3I Atlas as a natural comet with unusual but explainable properties. Perhaps it's a comet with a thick crust that vaporizes differently than expected. Perhaps its composition is rare but still simply unnatural. Perhaps we simply don't understand comets as well as we thought. But Loeb counters with a powerful point, drawn from his exchange with Wynn. When detectives arrive at the scene of a crime, should they ignore unusual facts because they didn't forecast them before arriving? He argues that science progresses precisely by investigating anomalies. Quantum mechanics emerged from anomalies in classical physics that couldn't be predicted beforehand. The photoelectric effect, black body radiation, phenomena that broke the rules, hot Jupiters, gas giant planets orbiting impossibly close to their stars were never predicted. They violated every model of planetary formation. Yet when we finally looked, we found them everywhere. The absence of prediction doesn't invalidate observation.
That's good. Lock it in place.
The Galileo project, founded by Loeb in 2021, is now developing instruments specifically designed to detect and analyze anomalous objects like 3I Atlas. Not to prove aliens exist, but to rigorously test the hypothesis with better data. They're building a network of telescopes equipped with advanced sensors, cameras that can capture high-resolution images of fast-moving objects, spectrographs that can analyze composition in real time, AI systems that can detect anomalies without human bias. The goal isn't to confirm preconceptions, it's to be ready when the next interstellar visitor arrives. Secrets with it. Heading toward whatever destination lies years or centuries ahead on its journey. We may never know the truth about 3I Atlas. The data might remain forever ambiguous. The debate might never be settled, but its passage has changed something fundamental. It's forced us to confront a question we've avoided for too long. What are we actually looking for? And would we recognize it if we found it? We've spent decades listening for radio signals, searching for technosignatures, looking for artificial structures around distant stars. But what if the evidence is simpler? What if it's an object that moves wrong, reflects light wrong, contains materials that shouldn't naturally occur together? What if first contact isn't a message but a mystery? Pause, 2 seconds. The next interstellar visitor could arrive tomorrow, or a decade from now, or a century from now. When it does, we'll be watching, and thanks to 3I Atlas, we'll know what questions to ask. We'll have instruments designed to gather the right data. We'll have protocols for distinguishing natural from artificial. We won't make the same mistake twice. We won't let the evidence slip away into the dark. The universe has sent us a message. We just haven't fully decoded it yet. This is MindOrbit, where we explore the mysteries that challenge everything we think we know. If you found this investigation compelling, there are countless other cosmic enigmas waiting to be explored. The Hubble tension that's breaking cosmology, The fast radio bursts that repeat in patterns we can't explain. The planets that orbit stars in impossible configurations. Subscribe to join us as we venture into the unknown edges of science, space, and human understanding. The universe is far stranger than we imagine, perhaps stranger than we can imagine.